Hello everyone, welcome back to Learn to Code in Python. So today's our day 6 in our 4-month interview prep plan. So as we saw in the past 5 days, we were trying to cover array related problems in data structures and algorithms. So we have covered many problems in the past 5 days related to array sorting, array rotation and advanced array two-pointer techniques and so on. So today's problems are related to array search, and I've picked two interesting problems using words. So one problem is word search, and then second problem is we'll be creating a dictionary where you'll be able to add words, search words, etc. So let's dive right into the video. So let's start with the word search problem. So in the word search problem, basically what it is this. You have an grid of words or characters. Sorry. Yeah. Given an M and N grid of characters called a board and a string word, we just need to return true or false if the word exists in the grid. The word can be constructed from the letters of sequentially adjacent cells, meaning you can either go horizontally or vertically to the neighboring cells to figure out the next character in the word. So in this board ABCE, SFCS, and then ABDEE, if you want to find a string of ABCCET, what you need to do is you need to start from A and then index 0 and 0 to 0 comma 1 and then 0 comma 2 and then 1 comma 2 and then 2 comma 2 and then going back to the last character. So this is how you will be able to figure out whether this particular word or this particular string is there in the board or not. So right now, to visualize this in a better way, I've created a simple visualization tool. So for example, this is the grid which we saw in the problem. So A, B, C, E, and then S, F, C, S, and then A, D, E, E. So for example, I want to search a string of SCFTA if it is available or not. What I'll be doing is I'll be going through a loop. First thing is I'll be going through the loop and I'll try to figure out the first character of the word. If it is there, then all we need to do is we just need to go check up, right, and then left and so on to figure out where is the remaining set of characters in this word. So that's what I'm going to do first. So initially when the loop starts, it will be going through and checking first each and every character, and we were able to figure out S is there, and then we were able to see it at the 1 comma 0 index. Next character of C is not there in the adjacent uh, places in the grid in the board. So what we'll be doing is this S is skipped. So we'll try. The loop will still go ahead and we'll try to see the next S. The next S is available here. So it's at 1 comma 3. So next, what is the character we want to find? It is C. So now we will go and see this 3 adjacent characters, and then here we are able to find C. The next step is to find F, and then here you have 4 adjacent characters, and this one is since already visited, you cannot go back, but you can go to either of this. So this will be going to F, and then again now we have 3 more adjacent characters, and then it will go to D and then to A, and finally this word is found. So that's how we are able to figure out how this whether the word is available or not. So what I have explained right now is a depth first search. So basically you are finding a character, and then you are trying to check the you are going in depth first, meaning you will be checking the next character and so on till you are able to get the all the characters. So let's just dive into the code and see how I've written it. So as I said, we will start with a loop figuring out if the first character of the word is there or not. So if the first character of word is there, then we'll be calling the step first search function. This function with row and column index, and then the index of the word index of the character in the word, will pass it. So if the index is equal to length of the word, then we will be returning as true. So this will make sure that our depth first search will be returning as true at the end if we find all the characters. And then if row or column index is going out of the bounds, or if the word is not equal to index, then we'll return it as false. So if the particular character is not matching with that index row and character row and column section, then we'll return it as false. So for on a temporary purpose, we just want to mark that particular character. So for example, first I figured out a is there in this one, and I don't want to return in here, right? So I'm marking it as hash, so that even though if I search from B, if I search look back to the left, I'll not be able to match the word, so that will be always returning false. So now what we are doing is we are moving up on the all four directions. When we are searching on all four directions, so the index of r plus 1 and then c, and then r minus 1 and c, and then r and then c plus 1 and then r and c minus 1, we are checking the next character in that particular word on all four directions. And since we are already marking the previous words with hash, we'll not be repeating it. And after this particular logic is this particular four function calls will either return true or false based on whether the next word is there or not, and if the next word next character is there or not. So if it is false, then basically it'll return it as false, that's it. Or if it goes through a long or in the entire depth of the word, then we will get true. And since it's an or condition, if any one of it is true, then we will be returning it as true. So that's how I've solved this particular problem. So this is very interesting and very easy to solve using depth first search. And let's move on. Let me try and submit it, and then we will move on to the next problem. Okay, the solution is accepted. So let's move on to the next problem. The next problem is even more interesting, and it is also using words. So this problem is we need to design a data structure that supports adding new words and finding a string if a matches any previously added string on that data structure. So for this, we need to implement a word dictionary class, and then the word dictionary class, you need to have these two functions, and then word dictionary initialization will be just, when you call word dictionary, you need to initialize that object, and then initialize the dictionary, and then when you call a add word, you will need to add a word into that dictionary or that particular data structure. And when you call a search, basically you need to return either true or false based on that particular word availability in the object in that word dictionary. So in the search, there is an option to pass dots inside instead of character to figure out if that to use an reject search, like wildcard search. So if it is passed as dot, we will be considering any word in any character in place of that particular dot. So this is a sample input, so we'll be having these all operations, and we'll be passing these all values. So basically word dictionary, the word dictionary, you are adding the word of bad, dad, mad and pad, and then you are searching for bad. And if it is available, okay, sorry, for these three are add and these four are search. So you're searching for bad. If it is available, then it should return as true, but it's not available, so it will return as false. And then if it is bad is available, so it's returning as true. And then dot ad, it is already available in two cases, so we are returning it as true. And then b dot dot, again b is there and then bad is there, so ad is there, so it will return as true. So on a high level, this looks very simple and straightforward. All we need to do is we just need to construct this new data structure which will accept this kind of words and then do this operation. So I have implemented this using the tree nodes. Basically, I am setting the tree node as root node, and then it'll have children's, and then if the end of word is true, then it means the that particular tree is ending. So the word dictionary's definition is looking like So basically we will whenever we are initializing the word dictionary, we will set the root node as the tree node, so that will be that will not contain any children, but that will just be the initial node. And then whenever you add the word, basically you will be adding the characters on the dictionary on the node, and then you will I mean you whatever characters are there in that word, basically those all will be becoming an one node on that particular tree. And whenever you are returning the end of the word, basically you will mark it as true. So on search, again we will be searching in the node. So if the character is equal to dot, then what we will be doing is we will be searching for all matching values. Like I will be searching for all values in that particular node children. And if not, we will just check if that particular character is there or not, or else we'll return it as false. So that's how on a high level I've designed this data structure. So this data structure will give an this data structure will allow us to add words and then search words. To better visualize this, I have created this visualization. So this in this I've already added some words. For example, let me put test as a new word. So this is actually the data structure, and again I didn't use tree like visualization, but I've used as a simple list. But you can understand these all are children of the main tree, and then the next children and next children, and then the last one is will be marked as true because that particular thing will be when last character will be marked as true because that will be the end of the word. So for example, now we want to check for first. So if I start the search with dot dot irst, so first it will go and see B and then A, and then third letter is D, so it's not matching, and then B and E, third letter is S, it's not matching, and then D and A, no, no, B and E, no, first. So now it's matching the all five characters, so it will return it as true. So that's how this particular logic works. Basically the tree nodes will, since I mentioned dot, it will search all the things. But for example, if I mention mad, okay, so what we will be doing is we will be going and checking the first okay, so the visualization needs to be rerun bad and then dad and then mad. So these three words I'm adding, and I'm searching for mad. So now it will initially go and search the word M, and then then it'll go for the next and next and next. That's how it'll figure out the words. And again, this visualization gives in a row-wise format, but again we can visualize this as a tree. That will be a more accurate description of or visualization of how this works. So that covers the two problems which I wanted to cover today, and these are simple and straightforward problems, but solving it in an interview might be a bit of a tricky situation. So it's just if you try and solve this multiple times on lead code, you will be able to solve it in on the fly during the interview. Let me just submit this solution and get a confirmation. If it is good, then we can move forward. Okay, it looks good and it is pretty decent. Okay then, so that concludes our video for today. So today we covered two word search problems, and this concludes our array related problems for our interview preparation. And again, this I mean the problems which I covered so far are related to certain patterns, and it covers most of the interview questions related to array or array related search or rotation or um, two-pointer technique and so on. But if you do want to learn more, you can start your search on lead code and solve more problems. And if you do find this video helpful, please do like, share and subscribe so that I can do similar coding challenges. And join me tomorrow for day 7, where we will start with another new topic and we will explore more. Thank you.